do we have evidence of a lake forming right there? I think we've got some evidence of it, and it's not really good. And I've been out with Andres Aslan, who's a professor at Colorado Mesa University. He's really, really excellent with working with young deposits like this. And he and I argued ourselves blue in the face. One thing geologists love to do is argue about stuff because, again, we weren't there, so, you know, we can come up with the darndest theories. And so he thinks that most of the sediments down there are wind-blown. And I think that there is some evidence of water all of a sudden piling up and the rivers kind of backstepping up to form little deltas, like you've got a Paonia Reservoir in the upper part of it today. And that we'd be dumping some mud in there. And there's some real muddy mud out on some of these mesas just up by Hotchkiss. But we really don't have perfect evidence, and remember how I talked about perfect geology, and we seldom ever see perfect geology. That evidence is so imperfect that we just have to maybe make some guess, and maybe someday some student from Colorado Mesa University will be out and work on that as a senior thesis. So the mapping that we do out here can bring up some really kind of fascinating points to it, but a lot of them are things that we really don't have the time to go in and look at them any closer. But it makes for a lot of kind of compelling things to look at the future, and that's one of the reasons geologists still have jobs. Is if the Hayden party went through here and figured this all out the first time they went through, who would need me? So there's always something to figure out in these areas, and the more you look, the more you find these kind of funky things going on, and you go, well, if that's happening here, what's happening up here? And so a map like this will tell a lot of stories, but if you look at them close enough or look at the deposits, you end up with a lot of really great mysteries too. And who knows if some of these mysteries will ever be solved?
How much further back do you have to go to get to the tropical that made coal?
Oh, okay. So the question is, how long ago until you're at the conditions that form coal? And we've got a little bit of coal in the Dakota that's just right below us here. That's about 95 million years old here. Whenever you see called carbonaceous shale, and when it's all dark, it's the coal. So there were some kind of tropical climates at that time. And then when we get up above Paonia, or up into the sides of Grand Mesa here, we've got all the coal mines that are up at Paonia. That was in the later Cretaceous, so it would be, around here, maybe 80 million to 70 million years ago. And that's when the ocean, the seaway that covered the continent right here and made all the adobes, it was filling in, and we were actually moving the beach and moving the land in and filling in the sea. And if you look at areas like that today, like if you went out to South Carolina, you would see that they've got all these beaches and barrier islands and tidal inlets and things like that. And then you go in back of them, and you've got all these tidal deposits, tidal creeks. You go even farther in where you've got some fresh water, and you get to places like the Snuggety Swamp and the Great Dismal Swamp. And those are all areas today where there's not much oxygen in the waters, and anything that falls in from the trees or anything, or the grasses growing there, it all gets preserved, and it doesn't oxidize away. And so that's the beginnings of what they would call a peat swamp right there. And it can form in tropical climes, but it also forms up into the Carolinas today, where it's not really so much tropical as just kind of warm, some subhumid areas. But that would be about the time that we had something very similar going on in this area. And so,
well ahead of the Salty Club.
Well ahead of that. And you know, the other thing that is part of the geologic story here is there's an awful lot of periods of Colorado's geology history that just don't show up right here. Our last rock deposits are Cretaceous in age and maybe 70 million years old, then the next deposits we find out here are on farther up the hill, and they're younger and younger, but they're all eroded away from where we are right here. And so there are vast parts of Colorado's geologic history and the climates at that time that we just don't have in this area right now. And we have to go elsewhere in the state to find those types of evidence. Well, I guess those are the types of things I wanted to point out to you. And now after you look down here, you know, at the first of the day, you look down here and you see this varied landscape, and it's really pretty. You know, it's got a lot of topography to it, and the topography kind of does these different things. Now when you look down, and I hope this doesn't kill your imagination or anything, but there's kind of a system to all this. There are all these things that happen during the geologic history of this area, not only to give you these bedrock cliffs that we see here, like the Dakota sandstone, but just during the glacial ages, the things that made this canyon leave these systematic deposits. And if you go out and look at them close enough, you can start picking the systems and figure out what they were through time. And once we know what they are, what they're made of, how they respond to different uses that we have, now all of a sudden you have the type of information where you can start making really great decisions about how to use the land. And it gives you a way to kind of appreciate the landscape a little more. That we're not looking at a one-shot deal here. We're looking at this culmination of all these different things that happened at different times. And in doing that, I hope, you know, the next time you see a geologic map, or the next time you even look at any of the landscapes around here, you just go, a lot of different things happened right here, and it tells a really great story. And you can recognize the changes in geology and hopefully appreciate them a little more. We're on a very active Earth here, and all we're seeing are the footsteps or partial footsteps of what's happened in these areas. But I think you'll agree, if you look at something like this, that there's just a rich, rich history